And then even when construction has been completed, watersheds with more development have higher sediment loads than watercourses with less development. The research we found that supported these points were studies using both paired watershed comparison approaches and pre to post construction monitoring approaches. This research showed that during active construction, the increase in sediments was 1 to 2 orders of magnitude greater than the undeveloped watersheds that they used in comparison, and that even when construction halted, the sediment loading into the watershed did not return to pre-construction levels. This can be illustrated more locally to our watershed too, as we show with these aerial photos. The image on the left is an aerial image of the confluence of the White and Bad Rivers, and the aerial image on the right is of the confluence of the Marengo and the Bad Rivers. In each of these images, you can see a distinct difference in the turbidity of the water where these river systems meet, as pointed out by the arrows on each. Both the watersheds of the Marengo and White Rivers are much more developed than the watershed of the Bad River and have known impairments. As our experts have and will testify, further development from this project will result in additional degradation of these watersheds and the other waters of the reservation. The last point I wish to make today is supported by the research is that sediment from human activities causes habitat and biodiversity loss, stream channel aggradation and flooding, and acts as a mobile substrate for other contaminants. This degradation impacts not only the environment, but human health as well, and costs billions of dollars annually in the US. Additional degradation to our water resources is ultimately a cost passed on from the applicant to tribal members, citizens, and local, state, and federal governments. We have a couple of case studies to illustrate some of the points we're trying to make about activities related to the proposed project increasing sediment pollution. The first example is related to the rock revetment that TC Energy installed along the Bad River to protect their 2 pipelines. TC Energy armored the right bank of the river where the pipelines crossed the Bad River during the winter of 2005 to 2006. This revetment was successful in abating the erosion where the line crossed the river, but we quickly saw impacts farther downstream with heightened erosion immediately after the construction site. This is because while erosion is a natural force, man-made alterations can easily impact the level and the location of erosion along a river channel. With riverbank revetment, erosion isn't necessarily reduced, but instead displaced further downstream, creating or possibly exacerbating erosion due to the redirection of energy. These maps show the analysis of the 2014 and 2019 LIDAR data and highlight the area in red where 16 meters of riverbank erosion happened within that 5-year time span. That area is immediately downstream of the revetment, which is the light green polygon. These images show the progression of erosion downstream of the TC Energy revetment. The image on the left is from 2005 prior to the revetment installation. The image in the center is from 2015, almost 10 years after, and the image on the right is from 2022. The circle highlights that area that was experiencing the most erosion is shown in the LIDAR analysis on the previous slide. This relates to the proposed project as the applicant is proposing to permanently armor 7 stream crossings during the construction process, including Bay City Creek, Little Bear Trap Creek, and tributaries to Deer Creek, Marengo River, Runsweiler River, and Gehrman Creek. 3 of these sites will include riprap, and those sites are Bay City Creek, Bear Trap Creek, and the Deer Creek tributary. And 4 of the sites will be armored without riprap, and those are the ones that are on Little Bear Trap Creek, the tribs to Marengo River, Brunsweiler River, and Garriman Creek. 6 of the above crossings are waters that flow directly into or onto the Bad River Reservation. And the 7th is Bay City Creek, which flows into Chequamegon Bay, and that Mr. McNerney showed has connections to the reservation waters through the Lake Superior herself. As visible in the above images with stream bank erosion that occurred after bank armoring, there is exacerbated erosion pushed downstream due to the displaced force of the river. That can happen on the proposed project as well. A second example we want to highlight regarding how man-made alterations to new areas downstream is a more recent project, and is the Enbridge stabilization of the Bad River meander on the reservation that happened this year. These images show both the log jack placement on the meander bank, which is the bottom left photo, and then the erosion occurring downstream on the opposite bank with the deflection of that current. So whether eroding due to natural forces, man-made alterations, or some combination thereof, completing stabilization of stream banks redirects erosive forces to new reaches. Habitat disruption and increased erosion can also have effects on water quality with increased erosion potential, and the risk of sediments and other substrates moving off-site becomes greater. Oops, how did I do that? There we go. Areas with geohazards are also a concern when considering sediment pollution. Long-term, these areas are more subject to failure, which could include mass wasting or other erosion that could introduce sediments to nearby water resources if they fail, but also if construction occurs at these sites to fix them before their failure. The Denemy Creek Tributary Project on reservation, where Enbridge identifies it as Slope 18 failed, and it was a known geohazard site that the applicant was aware of prior to failure. However, even with flyovers and periodic infield monitoring, the slope still failed, and the bed and banks of this tributary mass wasted into the stream at the bottom of the slope, leaving 40 feet of the pipeline exposed and impacting waters downstream and permanently altering the water resources of the slope. This case study will be discussed in more detail on future slides, but there was additional water quality impacts from this project, and there is the same concern for some of the geohazards along the proposed reroute. To conclude, sediment pollution from the proposed project will affect surface waters on the reservation. Monitoring the tribe has been carrying out for decades already shows that some of the rivers and streams on the reservation are already suffering impairments. Many from non-point source pollution like total phosphorus, total suspended solids, nitrate, nitrite, and E. coli. Increases in total suspended solids and turbidity from sediment releases from the proposed project will exceed the tribe's water quality criteria meant to protect the designated uses of waters on the reservation, including those for cultural designated uses and aquatic life and fish. And then we are switching to another pollutant of concern with Bridget presenting.
Bonjour, my name is Bridget Thornburg, and I am the Non-Local Beings Program Manager for Mashkazebe Natural Resources. I'm here to talk today about how this project will increase, oh, sorry, I forgot to switch this slide. Okay. I'm here to talk today about how this project will increase the amounts of biological materials such as the seeds and stems of invasive or non-local beings that are discharged into the waterways, which will travel downstream, polluting reservation waters and establishing new populations on the reservation. There are 247 wetlands documented on the construction route with reed canary grass. This map shows some of the documented populations at the proposed Bad River crossing, but this is not the full picture because reed canary grass is much more widespread than this map shows. Reed canary grass thrives in a variety of disturbed habitats. Its main requirement is full sunlight. This project proposes to deforest 101 acres of wetlands and 467 acres of upland forest, which will create favorable conditions for this species to spread. When the reed canary grass population expands in construction areas, both the seeds and vegetative fragments will be discharged into the waterways and float downstream to reservation waters. When it establishes in downstream areas, it will reduce the volume of water that a channel can carry and impede water flow, which can increase water temperature and cause flooding. Since 2008, there has been a dedicated effort to reduce the 75-acre garlic mustard population located along the Bad River in Mellon. As you can see in these maps, this population is very close to the reservation, and this project is proposed to cross directly through the population. The management of this area has been very difficult because most of the population is located in a floodplain. So each year, the entire area is flooded and the seeds shift around. Garlic mustard thrives on disturbance, so an important part of successfully reducing its population is reducing soil and vegetation disturbance. Construction directly through this existing population will create more disturbance, which will help the garlic mustard further overtake the area and increase the seed bank. Garlic mustard seeds spread through waterways, so the increased population size will increase the amount of seeds discharged into the water, which will travel downstream into the reservation waters and establish new populations. Garlic mustard releases chemicals that inhibit the growth of other plant species, hurting the native vegetation. So when control efforts to remove these new garlic mustard populations take place, soil erosion will increase into reservation waters because the garlic mustard will have outcompeted the other species living along the stream banks. Common buckthorn was documented within the project site 160 times. This map does not show all of these occurrences, but it does show the population located upstream of the reservation on the Bad River and near the Marengo River, as well as some of the existing populations on the reservation. This is another species that will thrive after areas are cleared for construction. The fruits of common buckthorn can float and remain viable in water, so as areas are cleared and the population expands, more fruits will enter the waterways, traveling downstream into the reservation waters and establishing new populations. Due to the shallow root system of this species, it does not hold soil in place well, which will cause an increase in erosion and degrade water quality when it takes over an area and outcompetes more deeply rooted native vegetation. Non-native cattail has been documented in 83 wetlands within the project site. This species has seeds that are dispersed by wind and water. The proposed clearing for this project will create new opportunities for the cattail to spread, which will lead to more seeds entering the waterways and traveling downstream onto the reservation. Non-native cattail will then establish in downstream areas on the reservation and outcompete native species, which will alter the wetland functions and hydrology that were provided by those native species. Purple loosestrife is documented in 2 wetlands within the project site. This map shows a purple loosestrife population located near the Bad River crossing and the current populations of purple loosestrife on the reservation. This is another species that thrives in conditions associated with disturbed sites, like construction sites. This top photo here actually shows a purple loosestrife population that is growing on the Line 5 corridor on the reservation. This species is incredibly good at spreading because each plant can produce up to 2.7 million seeds annually, and these seeds are as small as grains of sand and can float on water. So as this species expands due to the construction conditions, it will discharge seeds and plant materials into the water that will travel downstream and establish within the reservation, where it will outcompete native vegetation and alter the existing hydrology. Wild parsnip was documented 15 times within the project site. This species prefers sunny, disturbed areas, and the photos here show wild parsnip populations that are located along right-of-ways. This project will create more habitat for this species, and wild parsnip seeds can be transported via waterways, so as the species spreads through the newly disturbed landscape, its seeds will be discharged into the water and travel downstream onto reservation waters, establishing new populations on the reservation. The species can cause severe burns when it comes into contact with human skin, and that skin is exposed to sunlight, which makes it difficult to access and fully utilize the areas that it will spread to. The Wisconsin DNR conditions propose to prevent the discharge of invasive species into reservation waters will not stop the spread of these species. These conditions are vague and the wording used makes them unenforceable. They often refer to other documents, which makes it difficult to follow and will make it very difficult to implement. For example, Condition 85 refers to the ECP for pretreatment guidance, which states that pretreatment will only occur when possible, allowing the applicant to decide when pretreatment isn't possible. Without required pretreatment, there is a greater chance of spreading invasive species because construction activities could begin in an area with an invasive population that has not been controlled in any way. Then the seeds, which can be as small as grains of sand, will attach to equipment and personnel and be carried to other areas of the project. Conditions 89, 92, and 93 are related to cleaning equipment and refer to the ECP for decontamination protocols, which states that equipment may be cleaned to the extent feasible and that plant materials will be removed to the extent practicable. These are unenforceable conditions because the feasibility or practicability of cleaning equipment is determined by the applicant. As stated before, some of the seeds of invasive species are tiny, so even if extremely strict guidelines for cleaning and inspections were required, it would be impossible to completely ensure that no seeds were present on matting and equipment. For example, at the Denemy Creek riprap site, thorough equipment inspections were conducted and strict conditions were set. However, white sweet clover was still spread to this site through construction activities. The spread of invasive species that will be caused by this project is not just a nuisance. It will violate at least 3 of the band's water quality standards. Miigwech for your time.
Good afternoon. I'm Naomi Tellison. I'm the director of the Mushkegee Natural Resources Department with the Vadver Band. I was asked to spell my name, Naomi, Naomi, Tillison, Tillison. I'll be continuing the band's discussion of how many pollutants. Just one sec, let me make sure I can advance this. Oh, I have to use the arrow. Perfect, thank you. I'll be continuing the band's discussion of the many pollutants that will be released or mobilized by the proposed project and will flow into tribal waters, affecting water quality. The proposed project will change hydrology and will affect the water quantity, flow paths, and water quality in reservation waters. Multiple project activities during the construction and maintenance phases will alter hydrology and affect biological communities supported by the tribal waters. This includes over 33 acres of wetlands that will be permanently converted to different types for the installation of the pipeline. These forested and scrub shrub wetlands will not be restored, but rather they will be maintained as lower quality habitats. These permanent conversions will change wetland functions and quality and result in the loss of current functions and affect the quality of tribal waters. Blasting south of the reservation will result in hydrologic alterations, including changing groundwater levels and flow paths and groundwater surface water interactions, as discussed in detail by Limnotech. Blasting will dry up wetlands, it'll drown wetlands, and change flow rates at seeps and springs. These hydrologic changes will affect tribal waters and the biological communities and other uses supported by them. The matting placed in wetlands and uplands to support heavy equipment and other traffic will compact soils. This compaction will change topography, flow paths, infiltration, and other functions. Research has concluded that construction of a pipeline led to soil compaction, and then a combination of compaction and soil mixing changed soil water holding capacity, and thus altered hydrology, soil sediment chemistry, and invertebrate and wetland plant habitat. There have been impacts to uses and water quality effects when these mats were used for projects within the reservation, including the matting used to cross wetlands as part of Enbridge's project to install a valve on reservation last summer. After the matting was removed, there was over 6 inches of soil compaction as shown in this photo. We heard from water engineers how the change in land cover due to the project, including removing forests and soil compaction, will result in hydrologic changes in multiple streams and rivers at the location where they flow onto the reservation. Research has also shown that subbasins at or near the tipping point of open agricultural land and young forest increases runoff that adversely impacts stream morphology and water quality downstream. Furthermore, we just heard from Bridget about how the introduction and spread of non-local beings will affect hydrology and degrade water quality. Other projects with similar activities to the proposed project have resulted in water quality effects within the reservation. For example, the construction, maintenance, and operation of Enbridge Line 5 pipeline within the reservation resulted in pollutants or human-induced changes to hydrology, waters, and sediments in Denemy Creek watershed. Because of pipeline construction activities that were then worsened due to pipeline maintenance, the hydrology in the Denemy Creek tributary area shown on the map was degraded. This map is based on LIDAR data. On the right-hand side of the map, you can see 2 watercourses that are re-diverted by the pipeline corridor to flow to the west to join another tributary, instead of flowing north as they originally did before the pipeline activities. This hydrologic change led to increasing flows and erosion downstream as more water was diverted down this westerly flow path than originally occurred. The hydrologic change due to the pipeline activities eventually led to this slope failing, discharging sediments downstream and exposing over 40 feet of the pipeline. Enbridge implemented a project to rebury the pipeline. This project resulted in permanent losses of the Denemy Creek tributary and her riparian wetlands by replacing them with an engineered riprap channel. The project resulted in substantial wetland impacts due to access that have lasted over 5 years, as the project has not yet met the stabilization criteria in the permits and approvals issued for the project's water quality impacts. Due to the design and implementation failure of this pipeline project, the project resulted in more water quality effects by expanding the workspaces and filling in more wetlands and surface waters than proposed in the application materials, and by the effects lasting for a longer duration than originally planned. The project's application materials also did not accurately describe or map the surface waters within the proposed project footprint. This problem stems from the inadequacy of accurate waterway and wetland mapping in our area, which Esteban discussed earlier. A wetland delineation to collect field data was completed by the permittee's contractor in September 2019 after the pipeline was exposed. And although this delineation improved the mapping of waters at the project site, it still missed mapping wetlands and waterway features that existed at that time. This contributed to more water quality effects from the project activities than necessary. Wetland uses and functions were lost because of the riprap project. The surface waters missing by the mapping efforts are circled by a pink dashed line, and this includes wetlands adjacent to the drainage as shown by the green polygon. This green polygon included the wetland plants shown in the photo on the upper right-hand side of the slide and included culturally significant plant species. Also missing from the mapping was the rest of the intermittent watercourse connecting wetland C with Denemy Creek tributary at the base of the slope. This missing feature is shown by the pink linear polygon. This is where the pipeline was exposed due to the increased flows and erosion caused by prior pipeline activities. Please note that we determined the extent of these missing surface water features by reviewing photo and other data collected over a 5-year time frame, including plenty of documentation of water flowing downslope in this tributary before joining the Denemy Creek tributary at the base of the slope. Slide 32 is the last slide illustrating the hydrologic changes and other water quality effects caused by Enbridge's project to rebury the pipeline by filling in wetlands and a portion of a watercourse. The photos on this slide show what this slope looks like a couple years after the construction phase. You can see the riprap, corrugated pipe, and sediment basin that are now there. These engineered, man-made structures take the place of what used to be a watercourse and repairing wetlands, supporting uses that are no longer there. Another example of a similar type project having water quality effects on reservation is the construction of the Enbridge check valve project in the Sugarbush Creek drainage. The project to install a valve affected water quality by changing hydrology and wetland functions and uses, along with the increased sedimentation that Jessica previously discussed. Additionally, the valve project caused degradation to wetlands as illustrated by the figures and photos on this slide, along with prior slides. Vehicle traffic did not remain on the construction matting as planned, thus damaging vegetation, compacting soils, and causing additional rotting in the wetlands as shown in the aerial imagery on the left-hand side. This imagery also shows area where matting placed through wetlands and uplands for project access caused significant soil compaction and altered the elevation of the substrate. Both factors affect the hydrology of the site and the success of restoration of the areas disturbed. Recall that the photo included on slide 29 showed greater than 6 inches of soil compaction occurring due to the matting and vehicle traffic. The matting used for the check valve project was installed for less than the 90-day threshold the Corps uses to define temporary wetland impacts. Some of the matting was installed as little as 49 days at the locations closest to the valve installation site. The proposed project will have greater water quality effects than the valve project for a few reasons, including that the valve project had lighter equipment and less traffic than what is expected to be used during the construction of the proposed pipeline. Furthermore, there is no clear time frame for how long these mats will realistically be left in place for the proposed project. After these mats are removed, the site conditions for the proposed project will be unfavorable for the establishment of new vegetation, with the Wisconsin DNR recognizing it could take up to 24 months for vegetation to establish. The lack of vegetation for this time period will lead to the formation of new drainage ravines and gullies. The hydrologic changes caused by the proposed project will violate at least 3 of the band's water quality criteria and degrade existing uses, some of which are already impaired. Further hydrologic changes cause or contribute to other water quality impairments, including dissolved oxygen and temperature effects. Apologize, I advanced the slides a little bit too quickly. Mercury is another pollutant that will be discharged or mobilized by the proposed project and will enter tribal waters and will affect water quality and cultural wildlife, and aquatic life uses. Mercury concentrations in the surface water samples collected within the Bad River watershed are summarized in the table on this slide. Sampling occurred both within and outside the reservation. All 60 samples collected exceeded the band's mercury criteria developed to protect human health, which is more stringent than Wisconsin's mercury criteria. The chart on this slide displays the total mercury concentrations in nanogram per liter for the samples that were collected within the reservation. The first monitoring location listed on the x-axis is Tyler Forks River, followed by the most upstream site on the Bad River and moving further downstream to the site located at the mouth of the river. All 26 samples collected within the reservation exceeded the band's mercury criteria developed to protect human health, which again is more stringent than Wisconsin's mercury criteria. Total mercury ranges from almost 4 times the mercury criteria to almost 54 times the criteria. Even if we look solely at the methylmercury component of the results and exclude the inorganic form of mercury, the majority of the samples analyzed for methylmercury were also above the human health criteria for total mercury. The proposed project will increase transport and methylation of mercury in reservation waters, and this will be further discussed in the next presentation. Tribal waters already exceed the band's criteria, and fish consumption advisories are already in effect in tribal waters due to mercury pollution, restricting the amount of fish community members can safely eat. This slide shows the fish consumption advisory due to mercury pollution that is already in effect for Lake Superior and her tributaries, including the Bad River. Bad River tribal members rely on harvesting walleye from reservation waters to feed themselves, their families, and community elders. Bad River is the closest and most reliable location for tribal members to harvest walleye. Advisories that limit the safe consumption of fish are currently in place due to mercury pollution, including the off-reservation lakes listed on this slide. Red indicates no meals of walleye can be safely consumed from the lake. Orange indicates only 1 meal per month. And yellow indicates only 2 meals per month can be safely consumed from a lake. When concentrations of mercury and methylmercury increase in reservation waters due to the proposed project, then a tribal member will have to travel an average of 45 minutes to a lake that also currently has consumption advisories and has lower quantities of walleye present. All these factors reduce the amount of walleye a tribal member can harvest due to the water quality impairments. PFAS is a group of harmful pollutants that will be discharged by the proposed project and will enter tribal waters and will affect water quality in cultural and other uses. The proposed project has many different sources of PFAS that will be discharged. PFAS are in products designed to lubricate, emulsify, or decrease surface tension. PFAS containing materials will be used from preparation stages of construction and will continue during future pipeline maintenance. Pesticides or chemicals used to control invasive species are likely to contain PFAS, along with tactifiers used to manage soil piles. HDD drilling fluids also contain PFAS and corresponding inadvertent releases that were previously discussed. Fish consumption advisories are already in effect due to contaminants, including a type of PFAS. Advisories are in effect for fish harvested from Lake Superior and Bad River. The PFAS pollution increases caused by the proposed project will affect reservation waters and will violate at least one of the band's water quality criteria and degrade existing uses, some of which are already impaired. Blasting will expose new sulfide minerals to air and water, speeding up the rate at which these minerals release acid and heavy metals into the environment. These will generate pollution similar to mine pits, which will contaminate surface and groundwater systems. This more acidic water will also increase the need for routine maintenance from additional corrosion to the pipeline. Additionally, the rate of acid drainage generation would not be at a consistent rate. A report from EPA shows that the rate of acidic product generated depends on a few factors, such as wet and dry cycles, temperatures, and bacterial species present. With wetting and drying cycles regulating the rate at which this acidic waste is released. During years of average rainfall, these newly exposed rock faces will release acidic drainage in a constant trickle into surface and groundwaters. Within the last 20 years, we have experienced several periodic droughts as shown on the chart. Droughts have been increasing in frequency due to human-induced climate change. While droughts are occurring, acidic products will build up within the trench. Then during a large rain event, these acidic contaminants will be flushed out of the trenches into the streams in a large slug. This will affect tribal waters. The proposed project involves blasting 5.5 acres of shallow bedrock within the Moringa River, Bad River, and Tyler Forks watershed, as shown on the map. By the effects of blasting will mobilize both human-introduced pollutants like ammonia, nitrate, fuel oil, and PFAS, as well as expose and mobilize sulfide minerals containing selenium, arsenic, mercury, among others, into the environment. As recognized in Wisconsin DNR's final environmental impact statement, blasting agents utilized by the project include a mixture of ammonia, nitrate, and fuel oil, which is highly soluble compound and has the potential to release nitrate, nitrite, and ammonia into soil and groundwater. Ammonia toxicity is dependent upon pH and temperature and increases as both pH and temperature increases. Furthermore, HDD drilling fluids used in the project contain sodium carbonate, which can significantly increase the pH of receiving waters and thus increase the toxicity of pollutants such as ammonia. Minerals such as selenium, mercury, uranium, and lead are known to occur within the Pinocchi Range. These minerals will be mobilized similarly to the sulfides and build up within the trenches and released during precipitation events. Research on the effectiveness of erosion control BMPs also looked into their potential to release heavy metals into the environment, and research results showed that construction site BMPs release considerable amount of metals. Changes in temperature or thermal pollution is another water quality effect that will be caused by the proposed project during the construction and will continue into the maintenance phase due to the deforestation of approximately 467 acres of upland and over 100 acres of wetland. The project's blasting and other activities will cause alterations of groundwater and surface water flow paths. A pipeline transporting petroleum products gives off heat to its surrounding, as shown in the thermal imagery taken within the reservation. The Corps' analysis failed to thoroughly evaluate temperature effects, including failing to recognize that the proposed project has multiple activities that will change flow paths and surface water temperatures. The loss of forested and scrub shrub wetlands will impact water temperatures, wetland functions, invasive species, and flows downstream. Some of the non-local beings that Bridget discussed earlier are known to alter water temperatures after they invade into a new wetland or within a stream channel or riparian habitat. Temperature changes to groundwater and surface waters from the proposed project will impact surface waters and their ecosystems, both at the location within the maintained pipeline corridor and downstream. The chart on the right is from the 2014 final supplemental environmental impact statement that analyzed expected temperature effects from the proposed Keystone XL pipeline, showing measurable effects both subsurface and at soil surface. Temperatures measured adjacent to the pipeline were the warmest, although temperatures measured 11 feet away from the pipeline were still warmer than background temperatures. Elevated temperatures due to the pipeline occurred throughout the entire year. The image on the left shows elevated soil temperatures due to a pipeline measured at 6 inches below ground surface in Sioux Falls. Temperature increases adversely affect cold water fisheries and other aquatic life, including benthic invertebrates. Temperature changes and changes in groundwater levels greatly change the dissolved oxygen levels in cold water streams. These changes impact aquatic life within these habitats. Rising temperatures in streams exponentially increase toxicity of many chemical and heavy metal pollutants, impairing fisheries and other aquatic life. Miigwech. Thank you.
Dr. Brandburn, are you online?
Yes, I'm here. Can you hear me clearly?
Yes, we can. We have your slides up. We're going to project them for the online audience to see. And then we'll have someone in the room changing the slides for you if you just cue us.
That's great. Thank you very much. I can't see them on my screen yet. I can only see the ground rules slide.
One second, we should have it visible momentarily.
Great, there we go. Thank you very much. My name is Brian Branford. I'll spell it for the record. It's B-R-I-A-N, B-R-A-N-F-I-R-E-U-N. And I'd like to thank the Commander in the Armored Corps for this hearing, as well as Miigwech, Mr. Chairman, and the Bad River Band for the opportunity to present on this issue. Naomi Tillison, who you just heard from, asked me to consider the findings of other experts that you've heard from today and formulate an opinion about the effects of the Line 5 reroute on mercury cycling in the Bad River watershed, and I'm happy to be able to do that and present my opinion to you today. So next slide, please. So what I'm going to tell you about a little bit is about myself and a summary of my opinion. I'm also going to provide you with an overview of the mercury cycle, because the mercury question in watersheds such as the Bad River and its tributaries really actually has very little to do with the absolute amount of mercury that's there. It has much more to do with the other biogeochemical processes that occur that result in mercury becoming available to organisms and ultimately to people. We'll explore a little bit, based on existing data, whether the Bad River watershed is sensitive to mercury contamination, methyl mercury contamination in particular, and we'll discuss why in fact it is. It's a bit of a rhetorical question, and then discuss what the impacts of the proposed project on methyl mercury production and loading will be. Next slide, please. So my area of expertise is in mercury biogeochemistry. I've been working on these questions for approximately 30 years, both as a graduate researcher as well as a university research professor. My work is in the area of wetland hydrology, biogeochemistry, mercury methylation, as well as the interactions of those processes with climate change. I got my PhD 26 years ago this year from McGill University in Montreal, Canada, and I've been a university professor since I completed my PhD, first at the University of Toronto, and for the last 15 years as a professor and Canada Research Chair at the University of Western Ontario in London, Canada, where I am today. In addition to sort of all the traditional academic evidence of qualifications that you can find, I've also made a lot of expert contributions in both Canada and the United States, the state of California, reviewing proposals and work by the US DOE and the US Forest Service, as well as Canadian federal and provincial agencies. And work related to this hearing, I've completed in the state of Minnesota, as both from a research perspective, working in collaboration with the US Forest Service there and their Marcel Experimental Forest, as well as working with Fond du Lac and Minnesota Power on issues related to the St. Louis River mercury contamination. And I've also worked with other Ojibwe nations in Canada, including Grassy Narrows and Pick River, who have been affected by legacy mercury contamination in the past and still suffer from those effects today. Next slide, please. So in reviewing the information that I've had available to me, it's very clear to me that hydrological and biogeochemical changes to wetlands as a result of the Reroute project will increase the amount of methylmercury produced in the Bad River watershed, and that those increases in methylmercury will violate the band's water quality standards. The impact is a result of the project intersection of over 2,000 acres of hydrologically connected wetlands, and I'll explore that number a little bit later in this presentation, and subsequent changes to hydrological and ecological characteristics that enhance the process of mercury methylation. So that is the process that forms the more toxic and bioaccumulative form of mercury, methylmercury. This increase in methylmercury production will cumulatively contribute to a methylmercury load of an already mercury sensitive watershed, and it's already sensitive with exceedances of mercury levels in fish that are of concern to human consumers. Additionally to this, there are other violations of standards that relate to impacts on biodiversity and other organisms that are affected by exposure to methylmercury in the same way that humans are, and those concerns should also weigh quite heavily in our consideration of the impacts of this development on mercury in the environment. Next slide, please. And then just continue. Next slide. So to discuss mercury, we should just highlight a few points that have actually already been made today, so I won't dwell on these, but mercury is a high priority global pollutant because of its effect on fish consumers. And it's also global because it's released to the environment through a range of natural and human sources, primarily to the atmosphere. There are local consideration of sources of high contamination from industrial sources, but the more widespread and concerning contamination is from the mercury that's distributed globally from a range of sources. And human activity since the Industrial Revolution has increased mercury concentrations in the environment anywhere from 3 to 10 times, depending upon your source. Dominantly, the mercury that's released to the environment is in its inorganic form, but it's much more toxic in its organic form, and we're really going to dig into that a little bit because it's a critical point to the consideration of the impact of the project here. Just so that we're completely clear about some of the terminology that's thrown around mercury in the environment, elemental mercury, which is the neutrally charged form, exists as both a liquid and as a gas. So as discussed earlier, it can partition into the atmosphere or be emitted when it's heated. Inorganic mercury is an ionic form of this, which tends to bind to things. So it binds to constituents in water, it binds to plants and soils. And this is the most abundant form in the environment. It's inorganic mercury that's bound to something. Methylmercury is the organic form of mercury that bioaccumulates in organisms and is potentially neurotoxic. Is potently neurotoxic, not potentially, it's absolutely neurotoxic. Total mercury is often a value that's expressed in the literature and in presentations. And just to be very clear about this, total mercury is simply the sum of all forms of mercury in a sample. It's an operational term because of the analytical techniques. What really, when we're talking about the real chemicals, we're talking about methylmercury and inorganic mercury. Next slide, please. So in almost a cartoonish, simplified way, elemental mercury circulates in the atmosphere through various chemical processes illustrated by a magical arrow inside of a cloud in the diagram on right. It's converted to inorganic mercury through complexation, primarily with halogens in the atmosphere. That results in it being deposited in rain and snow. It's also taken up directly by plants. That inorganic mercury deposits along through the red arrow in this diagram and it starts to become involved in a range of biological and chemical processes in a primarily, our prior conception is primarily in aquatic environments where that inorganic mercury or Hg2 enters ecosystems, is converted through biological processes into methylmercury, which in the diagram on the right is denoted in the yellow arrows and boxes. which then becomes involved in the food chain through the process of bioaccumulation. That fraction of mercury that's in the red that's converted to the mercury in yellow is a very, very small fraction in most environments, usually less than 1%. Amazingly, even that very, very small amount is sufficient to result in fish consumption advisories in many, many parts of the world that are mercury sensitive. Methylmercury is dominantly formed in the environment by bacteria, and specifically the sulfate-reducing bacteria. Next slide, please. The sulfate-reducing bacteria convert inorganic mercury to methylmercury through kind of a metabolic byproduct. They don't mean to do it. They're basically detoxifying their own cells to the best of our sort of knowledge about the function. But a sulfate reducer's primary job is to reduce sulfate and produce sulfide. That's how it produces energy, metabolic energy for itself. And so it's eating organic matter, it's breathing sulfate, and then the byproducts of that metabolism is carbon dioxide through decomposition, and sulfide, which we recognize as sort of the rotten egg smell that we often will detect as we walk through some mucky wetland sediments. When a sulfate reducer that is simply doing its thing bumps into an inorganic mercury in the environment, it has the potential to convert it to methylmercury. And that is the primary mechanism that we're interested in here with respect to mercury as an environmental pollutant. So sulfate reducers can only function in oxygen-free environments, so anaerobic environments. Because they're bacteria, their activity is positively related to temperature, so there's be more sulfate reduction and mercury methylation with warmer temperatures. And the kinds of places where we typically thought that these kinds of things would occur, and this is in the diagram on the right, the top diagram, we usually conceptualize these places of conversion in deep lake waters, lake sediments, oxygen-free deep waters. But we've come to learn more recently that there's a much more diverse kind of places in the environment where methylation happens, and wetlands really stand out as a heavy hitter for mercury methylation in the environment, but also riverbank sediments, hyporheic zones, as well as wet forest soils. Next slide, please. So wetland sediments are often the locations in watersheds that absolutely dominate methylmercury formation and transport because they're along the flow path. They are often intervening landscape units between the upland environment and aquatic systems, and they support the biogeochemical conditions that are required for methylation. So in this cartoon, we have the pie chart where the red pie, part of the pie is the fraction that's methylmercury. Very little comes from the atmosphere. A small amount is produced in dry upland soil waters and runoff. In the catchment or in the watershed, the vast majority is produced in wetland pore waters. The amount can decrease when it enters lake water because of various processes that degrade methylmercury. But really the important part of this story is that the vast majority in a mature fish, a mature piscivorous fish like a walleye or a northern pike, pretty much 100% of the methylmercury that's in that system, that's in that organism is methylmercury. Okay, next slide, please. We've known for quite a long time, in fact, that wetlands are sites of methylation because of these permanent or transient anaerobic conditions. And from a great paper by James Hurley in 1995 in Wisconsin, a very nice survey of surface waters in Wisconsin demonstrated that any watershed that has significant wetland cover has a much greater potential for methylmercury formation. And I refer back to a paper in 1995, not because there aren't dozens and dozens of papers since then, but because our opinion about this hasn't changed in 30 years. This is a very, very clear finding and an excellent paper done in the state of Wisconsin that I think is very relevant. The top table in the middle of this slide highlights for us a couple of important values. The median value of the percent of all mercury that exists as methylmercury in surface waters in watersheds that are dominated by wetlands and forests. And there's two different seasons here, and there are some important sort of implications there for variability over the course of a year. And this is obviously, to some degree, a temperature-related effect. But the percentage of mercury that's in the environment as methyl mercury in these wetland-dominated systems, based on this data, about 3 to 6% of all mercury is methyl mercury. And I did mention earlier that typically in most environments that aren't really strongly methylating environments, a value of 1% would be considered pretty typical. So when we have numbers that are this large, this is a fairly significant fraction of methyl mercury that's in waters. In the lower table, we have some other information. The last column is watershed transfer efficiency, where values above 1 are very efficient, values below 1 are less efficient. So we have a much higher watershed transfer efficiency of methyl mercury in wetland and forest systems, particularly in the spring, during the spring freshet. Okay, next slide, please. So overall, I think it's useful to think about controls on methyl mercury, which again is really the only form of mercury that we're concerned about when we're talking about bioaccumulation and exposure to fish-eating consumers. It's useful to think of this as kind of a baking analog. We have 3 key ingredients that we need. We need inorganic mercury, obviously, to convert to methyl mercury, but in most environments, this is not limiting, despite it being a trace contaminant. There's plenty of inorganic mercury that has fallen from the sky in the last 100 years to support mercury methylation in most environments. We need organic matter because microbes can't function without organic matter being present to donate electrons as part of their metabolism. And this can be limited in some environments, particularly when we have organic matter that is of differing quality for organisms to metabolize. But importantly, organic matter also serves as a transport factor for mercury in some environments because mercury binds and methyl mercury binds to dissolved organic matter in runoff. Sulfate is obviously necessary for the activity of sulfate reducers. This can be a limiting reactant in some environments. However, it can also be supplied in pulses. We've heard already today, I'm not going to discuss in detail about this, but we've heard how sulfide-bearing minerals can oxidize and provide sulfate to sulfate-reducing bacteria, and as a consequence, increase their activity. And of course, we have to have all these ingredients put together in a place that supports methylation, and those are anaerobic environments that in landscapes like the Bad River watershed are predominantly wetlands. Next slide, please. So if we start thinking about the controls on methyl mercury formation, there's 2 really key ones I think to consider, particularly in the context of wetlands where often organic matter is not limiting. If we add more sulfate, we will produce more methyl mercury. This is the top graph is a graph from some of my PhD work from way back in 2001, from work done in Sweden, very clearly showing with different numbers of amount of kilograms per hectare per year of sulfate being applied, we have significantly different levels, increases in methyl mercury in pore waters of wetlands. This isn't a wetland. We also can see from the Hurley et al. Work from Wisconsin that a greater proportion of the landscape that has conditions to support methylation, so as the bigger the oven, we will produce more methyl mercury and export more methyl mercury downstream. So that's not to say that mercury changes in the amount of mercury is not important. It is important, but it is proportionally less important than the amount of the landscape that can support methylation and the different reactants that are necessary for sulfate reduction to occur. Okay, next slide, please. Methyl mercury is really the important form of mercury that we're talking about here because it's the only form that bioaccumulates in biota. So that is, it's strongly retained in the tissues. In fact, the assimilation efficiency of methyl mercury is nearly 100% in organisms, particularly in fish. And then as a consequence of it being so sticky in organisms, it biomagnifies. So the higher the trophic level organism, the more mercury that it will have consumed over its lifetime through its diet. As a result of that biomagnification, methylmercury in high trophic level fish is typically 1 million times higher than the water in which it lives because of this process of biomagnification. Biomagnification, of course, continues into top consumers, which include birds and mammals and people. And we are exposed to elevated methylmercury through primarily through a fish diet. So the take home for the methylmercury story is that if methylmercury wasn't formed by all of these processes in the environment, there really wouldn't be a mercury problem, because we wouldn't have mercury in the form that bioaccumulates and biomagnifies. Okay, next slide, please. Why does this matter? I mean, I think sort of anecdotally, we all understand why this matters, but there really is a pretty clear proportionality between increases in water methylmercury, so how much methylmercury is produced in the ecosystem, and how much is in biota. There aren't places in the world where methylmercury is present in high concentrations, and yet the organisms have low values. It's a clear positive relationship. Methylmercury being the form that bioaccumulates and biomagnifies is the reason for this, and it impacts not just people, but also the behavior, reproduction, and survival of wildlife, and that includes fish. Important work that I've actually been involved in fairly recently, migratory songbirds, and then perhaps more obviously, birds and mammals that eat fish like we do are also negatively impacted. The primary exposure for humans and other fish-eating animals is from consuming fish that are contaminated with methylmercury. And as I've sort of alluded to, it doesn't really take a lot of methylmercury in the aquatic environment to result in a concerning level of methylmercury in a fish diet. Severe health effects of methylmercury on humans can be very severe and lifelong. And this can occur at levels which are currently considered from a regulatory perspective sort of quote unquote safe. Biologically, I think there's an increasing consensus that there really is not a safe level of methylmercury exposure for people who eat fish. Next slide, please. So the next question is the Bad River watershed sensitive to methylmercury contamination, which is a bit of a rhetorical question. Next slide. There isn't extensive data sets available on mercury and methylmercury in the Bad River watershed. However, there's clear evidence that it is sensitive to methylmercury contamination. Almost all of this discussion is from two sources: the U.S. Geological Survey in this open file report by Douglas Burns in 2020, as well as a presentation by Sarah Jansen from the U.S. Geological Survey in Wisconsin, also from 2020. Just as a little side note, the EIS document associated with this proposal is quite silent on the issue of mercury and is completely silent on the issue of methylation and changes in hydrology related to methylation. So I'm not speaking on that source for that reason. Fish mercury, based on the work in this open file report, is above Great Lakes consumption guidelines. The two bars in the graph on the right are walleye and pike. So not surprisingly, these highest level piscivorous fish have the highest mercury levels. The report also documents mercury levels in bald eagle feathers and otter fur, and those levels had mercury levels high enough to cause neurological impairment. Importantly, to my mind, the median value of the percent methylmercury of all mercury forms was 10.9%, with a range of 2.9 to 12.7 in the interquartile range. You'll recall from the work of Hurley, 1995, other Wisconsin watersheds were documented at 3 to 6. So 10.9, in my experience, based on that data, as well as other work that I've done, is an extraordinarily high percentage methylmercury. And because that rule of thumb for surface waters of that 1 to 3%, being for more sort of typical, greater than 3% and certainly greater than 10% is a watershed that is very, very efficient at converting inorganic mercury to methylmercury. When we have percent methylmercury this high in surface waters, the source of that methylmercury is unequivocally wetlands that are draining into tributaries. And Hurley et al. Again in 1995 established the baseline of this, and there's certainly subsequent scientific consensus around this term. Next slide, please. There's further quite sophisticated evidence that points to wetlands as the dominant source of methylmercury in the Bad River watershed. This is a USGS study reported on by Sarah Jansen and colleagues from Madison, Wisconsin, from the USGS Mercury Lab there. Comparison of the St. Louis River as a mercury contaminated site, as those are in the blue symbols on this graph, as well as the Bad River watershed as kind of a reference site relative to the St. Louis River, demonstrating that we have, based on the stable isotope characteristics of the mercury that was measured, mercury that's dominated by, in the system dominated by mercury has been transformed in wetlands and subject to high methylation processes in both wetlands and the watershed. Because the mercury stable isotope ratios are as they are presented here, there's no evidence of any serious industrial contamination of mercury in the Bad River watershed, which we wouldn't have expected. So all of this is quite consistent and makes perfect sense when we think about the percent wetland cover between the right-of-way and the reservation boundary. Based on work by Mr. Chiraboga and the Glyphwick, we have some percent wetland cover based on the new mapping, which is incredibly important to this story. And I'll highlight in particular the Tyler Forks watershed between the right-of-way and reservation boundary, where the percent wetland cover is an extraordinary high 37%. So all of our percent methylmercury information, this mercury isotope information, is all very, very consistent with a wetland-dominated watershed that is highly mercury sensitive. Dissolved organic carbon concentrations, as an aside, are also very high from the Burns report, and these are strongly correlated to dissolved methylmercury concentrations. Not a surprise, because both of them are wetland derived. So the Tyler Forks watershed, just in my asterisk there that I even missed for myself as a highlight point, these are the sampling locations that the USGS studied where the highest percent methylmercury was measured in the entire Bad River watershed. So again, not a surprise given the high percent watershed wetland proportion in the watershed, and that's that part of the system. Next slide, please. So what then are the impacts of the proposed project on methylmercury production and loading in the Bad River watershed? Next slide. Probably the most important consideration here is the fact that the area of wetland impact of this project is not just the right-of-way or the designated permit area, since it's perpendicular in most places to the hydrologic flow paths of extensive wetlands that control downstream flow and water quality. So based on those new LIDAR surveys, which are incorporated into the map that you see on the right here, this is the Tyler Forks Felcher wetland watershed wetland area. Over the entire project, and this is an incomplete wetland inventory as well, based on the new LIDAR data, as you heard earlier, we have 426 wetlands that are intersected by the project, and the total area of those wetlands is over 2,000 acres. So we actually don't really know what proportion of that area will be hydrologically impacted by the development, because we really don't have a good idea about what the upstream and downstream effects are. We heard earlier that the groundwater, doesn't see a pipeline and is largely unimpacted by its flow. With respectfully, the document that was provided to me describes a 20% variation for success criterion of downstream water table variation relative to upstream, which means that they're actually, based on my reading, an expected effect of water levels impact in wetlands that may be wetter or drier or more variable than natural conditions, and plus or minus 20%, whichever direction, will impact mercury methylation in different ways. Next slide, please. So wetter conditions bring the saturated zone of the wetland. So if we're plus 20%, that brings the saturated zone of the wetland closer to the ground surface. This increases the volume of the anaerobic zone. It also increases the temperature of the zone of methylation because we're simply closer to the ground surface. We've heard earlier about how clearing of vegetation may result in a warmer environment, which would contribute to enhanced methylation. Drier conditions promote the oxidation of surface organic soils that releases dissolved organic matter. It also releases bound mercury and also releases sulfate, which can increase methylmercury production in the saturated soils below. It can also increase methylation when we have more variable water level fluctuations that combine both of these mechanisms. The wetting and drying cycles have been demonstrated by work that was done at the Marcel Experimental Forest in Minnesota, that the more variable water table fluctuations quite dramatically enhance methylmercury production. This effect may not be just down gradient, since the project will also presumably also change up gradient hydrology, since we have a projected success criterion of plus or minus 20%. The graph on the right shows actually a recent experiment from a student of mine that did a wetting and drying experiment in the lab with some wetland sediments, and showed very clearly that the average percent methylmercury that's produced through these subsequent wetting and drying cycles is quite substantially higher in treatments with fluctuating water tables rather than a stable saturated condition, which was no slouch on its own in producing methylmercury, but certainly the fluctuating condition was further enhanced. Next slide, please. We've also heard there'll be changes in wetland plant communities through wetland conversion. This wetland conversion, we've also heard it will be in some cases documented as permanent, and in some cases the suggestion is that it's a more temporary conversion. However, documents that I reviewed, it was very clear that expert opinion was that many of these wetlands would take decades, if not longer, to revert back to, especially their forested condition like we see in the top image. The conversion of forested and shrub-scrub wetlands to emergent wetlands, which are more macrophyte dominated and have more open water, will do a number of things to affect methylation. The first thing that they'll do is change the plant community, which it doesn't just change, of course, the visible aspects of the wetland, but they also change the microbial function, converting these kinds of environments from more fungal dominated below ground ecosystems to more bacterial. And we really kind of like use the rabbit, the tortoise and the hare analogy here, because a fungal dominated ecosystem is sort of the equivalent of chewing on celery, low metabolism, sort of low carbon sort of turnover potential, whereas these more productive communities have much more rapid decomposition and much faster turnover and higher metabolism, which can increase microbial activity and increase mercury methylation. Those systems also characterized by increased hydrologic connectivity, which can increase downstream export. Next slide, please. So if we increase methylmercury production in the mercury-sensitive headwaters of the Bad River, we will deliver the additional methylmercury to receiving waters facilitated by the DOM that we've found in high concentrations in these systems. And this additional methylmercury will be bioaccumulated and biomagnified, which cumulatively contributes to the mercury load of an already mercury impaired system. The diagram at left on right shows us really this semi-log linear relationship between water methylmercury and methylmercury in much higher trophic level organisms like piscivorous fish and loons. An increase in the concentration of methylmercury in water simply moves us up the y-axis and increases concentration across the entire biological system. Next slide, please. In addition to downstream loading, we will also enhance hotspots of methylmercury production, which may be much more proximal to the right-of-way. And these kinds of hotspots of production will contribute to increased exposure to other organisms that interact with the ecosystem and consume aquatic insects as well as small fish. That exposure to things like songbirds is important. We've demonstrated in our own lab that dietary exposure affects flight endurance of migratory species and has negative effects on the carryover of migratory songbirds, resulting in decreased migratory success. And certainly there's many papers that document the effects of mercury on the health of wild birds, mammals, and fish. So those impacts are not just to fish and fish consumers, but also to other organisms that are impacted by enhanced methylation in the environment. Next slide, please. So this is my conclusion here really is that these changes to the hydrology will change the biogeochemistry of wetlands as a result of the REROT project, and the area of that impact is substantially larger than simply the right-of-way because of the intersection, the perpendicular intersection of the reroute to flow paths. And that increase will violate the band's water quality standards. Specifically, it's going to result in an increase in pollution that bioaccumulates in aquatic organisms and can contribute to adverse effects of consumers, and also the production of pollutants that will affect natural biological communities and wildlife habitat. It's my opinion that there are really no conditions that could prevent these violations given the nature of the change in landscape, as well as the location of the reroute project through these extensive and apparently largely undocumented until now wetland areas in important watersheds like the Tyler Forks. That's everything that I have for my presentation. Chimagwech.
We gained an hour through Tara's efficiency this morning, so we're actually going into our
Yep, here you go.
Bonjour, I'm Naomi Tellison, the Natural Resources Director for the Bad River Band. I'll be continuing the band's discussion of how the proposed project will release or mobilize pollutants that will flow into tribal waters and affect their water quality. Oh, okay, great. In this presentation, we'll discuss what constitutes a lowering of water quality and provide examples of how the proposed project will affect outstanding tribal resource waters, outstanding resource waters, and exceptional resource waters. We'll also discuss how the proposed project violates the band's anti-degradation policy and provisions in the band's water quality standards. The definition of the lowering of water quality is provided on this slide. Water quality encompasses the chemical, biological, and physical properties of a stream, wetland, or other surface water. The lowering of water quality includes the observed decline in water quality, and the photos on this slide are examples of observations of declined water quality. The lowering of water quality also includes the projected changes in water quality, and the chart on this slide that was developed by Wright Water engineers shows the projected changes in water quality in Tyler Forks within the reservation boundaries that is due to the proposed project activities. The lowering of water quality also includes new or increased loading of pollutants. The proposed project will cross 138 streams and rivers and over 100 acres of wetlands. And these two maps show the proposed project and the hydrologically connected reservation waters that are designated Outstanding Tribal Resource Waters, or OTRWs for short, Outstanding Resource Waters, or Exceptional Resource Waters, or ERWs. The tribe's OTRWs, ORWs, and ERWs that will be affected by the proposed project are listed on this slide. This includes the Bad River and her riparian wetlands and oxbows. This includes the Potato River and her tributaries and the springs connected to her. This includes the tribe's wild rice waters like Bear Trap Creek and the sloughs, and many other surface waters. Projected or observed impacts to tribal waters due to the proposed project include changing the physical integrity of these waters by altering hydrology, flow paths, and temperature. It also includes modifying the chemical integrity by introducing and/or mobilizing chemicals and pollutants. It also includes altering the biological integrity by the introduction and spread of non-local beings and diminishing the biological community supported by these waters due to all of the water quality effects. Mercury is a bioaccumulative chemical of concern, or BCC, that will affect the reservation waters due to the proposed project as discussed by prior testimony. We heard both about blasting and how that will influence mercury, and we also heard about modifying upstream wetland hydrology and how that increases mobilization of mercury and methylmercury from wetlands, soils, and peats. This is a concern for all hydrologically connected tribal waters. As we already discussed, tribal waters already exceed the band's mercury criteria, which are more stringent than Wisconsin's criteria, and the proposed project will increase mercury and methylmercury in tribal waters. As discussed in prior testimony, the proposed project will also release PFAS into reservation waters, and PFAS bioaccumulates. The proposed project will utilize many materials that contain PFAS, and as a result, PFAS will be discharged into surface waters and groundwater that are hydrologically connected to reservation waters and will affect tribal waters, including the Bad River, where a fish consumption advisory is already in effect for a type of PFAS pollution, which reduces the amount of fish that can be safely consumed. The proposed project will cross Bear Trap Creek and her tributaries, including Little Bear Trap Creek. Bear Trap Creek is an outstanding resource water and is an outstanding tribal resource water where the wild rice habitat is present. Bear Trap Creek's water quality is already impaired, and uses are currently not being supported on this creek. Current water quality impairments are due to excess sedimentation and nutrients, low dissolved oxygen, and inadequate road crossings affecting water quality flows and aquatic life. These water quality impairments occur both within and upstream of the reservation. Excess sedimentation is the most widespread non-point source pollution challenge in Wisconsin Lake Superior Basin, according to research. Excess sedimentation affects Lake Superior Basin streams by covering up important fish spawning areas and by altering stream hydrologic function that contributes to habitat degradation and makes streams less able to buffer effects from extreme flood events. We also know that excess runoff drives excess sedimentation. Bear Trap Creek watershed and Marengo River watersheds are the two subwatersheds within the larger Bad River watershed that have been documented to have the greatest water quality effects or the most degraded water quality. Photos on this slide show examples of current water quality impairments, including the high debris line, which is evidence of flashy flows, and a culvert perched by 9 inches that affects water quality, flow, and aquatic life passage. The proposed project will increase erosion and sedimentation in Bear Trap Creek within the reservation by trenching Bear Trap Creek and her tributaries, including Little Bear Trap Creek. It will also affect water quality on reservation by converting land cover by deforestation, compacting soils due to matting, heavy equipment use, vehicle traffic, and other project activities. We've already heard about Wrightwater's analysis that demonstrates the proposed project land conversion and compaction will increase discharge in this creek at the location where the creek flows into the reservation. Additionally, as part of the proposed project, bank stabilization of Bear Trap and Little Bear Trap are also being proposed, with stabilization including riprap and other materials. This will further exacerbate existing water quality impairments and affect the creek's water quality within the reservation. As I mentioned previously, Marengo River watershed also already has known water quality impairments, and these water quality impairments hinder the waters from being able to support existing uses. Considerable attention has been applied to the Marengo River because it is the greatest contributor of sediment to the Bad River, contributing approximately a third of sediment loading in the Bad River. The Bad River is thought to be the largest sediment contributor to Lake Superior in the United States. The current erosion and sedimentation rates that occur within the Bad River watershed, including within the Marengo River subwatershed, are not natural. It is well known that the current sedimentation rates in our area exceed natural sedimentation rates. Sedimentation rates are accelerated beyond what is naturally occurring due to deforestation and other land use changes that have occurred within the watershed. In addition to excess sediments and nutrients, water quality impairments in the Marengo River watershed include unstable hydrologic conditions and loss and fragmentation of aquatic habitat. These impairments are discussed thoroughly in the Marengo River Watershed Action Plan, which is an EPA and Wisconsin DNR approved 9-element watershed plan, developed and initiated over a decade ago. And this watershed plan was updated and reapproved in 2023. The proposed project's construction and maintenance activities will further degrade Marengo and her tributaries and further affect water quality within the reservation. One of these tributaries is Brunsweiler River, and the proposed project will cross Brunsweiler River only 2 river miles away from where this river flows onto the reservation. This figure is from the Marengo River Watershed Action Plan and was developed by the Fluvial Erosion Hazard Study Group. This group formed as part of a FEMA-funded grant launched by Ashland County after our area experienced flooding in both 2016 and 2018. This group included U.S. Geological Survey and other partners, and this group gathered data and evaluated opportunities to restore stream, floodplain, and wetland conditions upstream of vulnerable road stream crossings. This figure shows mass wasting risk in the Marengo River watershed. We overlaid the proposed project footprint on this figure. High-risk stream segments have valley sides greater than 50% slope. The areas within the soil transition and clay plain are most susceptible to excessive peak flow volumes, leading to erosion and sedimentation problems that in turn affect aquatic habitat and water quality. Brunsweiler River, Trout Brook, Billy Creek, Silver Creek, and other tributaries have areas of high to very high erosion rates as shown on this figure. The proposed project activities are planned to intersect these watercourses where they have high and very high erosion risk, which again will result in the proposed project further degrading water quality, including their water quality as they flow onto the reservation. Furthermore, the drainage on this figure that's labeled number 2, which is a portion of Moringa River drainage, and the drainage labeled number 10, which is Billy Creek, already have greater than 40% open lands and other concerning attributes that affect stream hydrology and water quality downstream. The tributaries to Moringa River and Brunsweiler River that will be impacted by the proposed project already have the same water quality impairments discussed for the Moringa River watershed. These tributaries include Silver Creek, Trout Brook, Billy Creeks, and other tributaries. Please note that Trout Brook and Billy Creek support cold water fisheries, whereas Silver Creek supports cool water fisheries. Current water quality impairments in Trout Brook, Billy Creek, Silver Creek, and other tributaries to the Moringa River, as described in prior testimony. This includes increasing erosion and sedimentation by various project activities. The HDD proposed to cross Silver Creek is described as significant and challenging crossing by the applicant and is the second longest HDD crossing proposed, and longer and deeper HDDs increase the risk of fluid loss. The proposed project will also alter hydrology as these waters flow into the reservation, as described by Brightwater engineers. All of the Moringa River tributaries have projected increases due to the proposed project activities at the locations where these waters enter the reservation. And on this slide, which contains a figure from Brightwater engineers, I would also like to direct your attention to Vaughn Creek. Vaughn Creek is a tributary to Potato River that flows within the reservation, and Vaughn Creek is also crossed by the proposed project. This tributary is located in the upper right-hand part of the slide. Vaughn Creek also already has known water quality impairments. This creek will also be affected by the different proposed project activities. Brightwater's analysis shows that the proposed project will substantially increase flows in this creek at the reservation boundaries. Unlike the other water bodies that I was just discussing, Tyler Forks River has good to excellent water quality conditions, both on and off reservation. The only known water quality impairment in Tyler Forks River is due to mercury, and mercury concentrations, as we've already said, exceed the band's water quality criteria. Macroinvertebrate surveys conducted on Tyler Forks result in a Hilsenhoff Biotic Index score that is rated as excellent. During the macroinvertebrate surveys conducted, there were 2 special concern species that were found. One of these species is a type of stonefly that is very sensitive to changes in nutrients and sediment loading. And please remember, macroinvertebrates or benthic invertebrates are organisms at the base of the aquatic food chain. So impacts to them will impact other levels of the food chain. The map on this slide was already discussed by Esteban earlier today. This map utilizes the most recent National Wetland Inventory data, which is more accurate than prior version of the mapping dataset and includes more wetlands and watercourses. We have repeatedly pointed out the inaccuracies in existing mapping of waters used in the application materials. And the most recent National Wetland Inventory improves the understanding of the hydrologic connections between the proposed workspaces and this river. And this river within the reservation boundaries. The proposed project will cross Tyler Forks only 3 river miles upstream of the reservation. Tyler Forks then flows south off the reservation and flows into the Bad River at Copper Falls State Park. The water quality of Tyler Forks within the reservation will be affected by the various proposed project activities, as we already heard in testimony provided earlier. It should be noted that at this cold water stream, the HDD crossing is proposed to be 50 feet wide instead of 30 feet and have 100-foot wide workspaces on either bank of the river. The water quality effects include what Ian presented about earlier in terms of increasing flows and changes to water quality. The Tyler Forks watershed has extensive microtopography, seeps and springs, and intact coniferous swamp ecosystems that will be impossible to restore to pre-construction conditions. Asbestos-like minerals are also known to be present in the Tyler Forks Basin, and blasting is being proposed in this basin. We heard from Limnotech earlier about the impacts due to blasting and other project activities. We also heard earlier about the USGS Groundwater Surface Water Interaction Study. In that study, USGS developed a model. For Tyler Forks River, most of the river was modeled as gaining, but the reach within the reservation boundary was simulated as losing by the model. And USGS wrote in the corresponding report, substantial leakage from the Tyler Forks River into the groundwater system is potentially important for the water resources of the reservation because it forms a potential source for contamination of the groundwater system with implications for the Potato River subbasin. Not only are we concerned about the water quality effects to Tyler Forks River from the proposed project, but we are also concerned about the water quality effects to her riparian wetlands. In the southeast corner of the reservation is where Tyler Forks and her riparian wetlands are, and there's a wetland complex of deciduous forested scrub, shrub, and emergent wetland types connected that are crossed by the proposed project. And the riparian wetlands shown and circled on this map are hydrologically connected to the project, not only by the river, but by the other wetlands that are affected by or crossed by the project activities. The 2 wetlands circled are currently supporting their uses. The overall floristic quality of the wetlands is medium, indicating that they are healthier wetlands that are still sensitive to disturbance and degradation. The average mean C, or how sensitive the individual plants are to disturbance, is 6.81, showing they are less tolerant to disturbance. In our monitoring of these 2 wetlands, there's only 1 invasive species currently present in one of the wetlands, and there's many culturally important plants present in this area. The project will cause or contribute to water quality effects to these riparian wetlands, including hydrologic changes through increased runoff flows in the river and changes in hydrology connected wetlands impacted by the project upstream. The proposed project will also increase sedimentation carried down from the construction site and access roads. Also from inadvertent returns associated with the HDD and other project activities. The proposed project will also increase invasive species as current infestation spread and grow due to construction and maintenance activities, and new species are introduced, leading to increased loading of seeds that will be carried downstream to establish in wetlands on the reservation. And Bridget previously discussed the water quality and human health effects due to bases. The hydrologic, invasive species, and other changes will degrade wetland, change their functions, and change the biological community supported in these wetlands. Many other surface waters, such as other riparian wetlands along Bear Trap Creek, Light River, Marengo River, Brunsweiler River, Bad River, Tyler Forks River, Potato River, and other tribal rivers and streams, are hydrologically connected to the proposed project. The map on the right was created by USGS to show the extent of the 2016 floodwaters within the Bad River floodplain, which includes many wetlands and oxbows. These hydrologic connections between the wetlands and oxbows are present at river flows substantially less than the 2016 flood flows. Okay, let me try that. Oh, sorry. Up. Oh, perfect. Thank you. I was just trying to do the best with the setup, so I do appreciate that. Okay, maybe I'll do one more to try to get the full. Okay, thank you. Oh, whoops, went too far now. Okay, good, thank you. Okay. The ban's anti-degradation provisions contained in the water quality standards state new or increased discharges and alterations of background conditions are not allowed in OTRWs. The application materials acknowledge that new or increased discharges or alterations of background conditions will occur. The RPS report states nearly all the discharge bentonite eventually settles within the model domain, meaning the Bad River, regardless of the river flow rate. The greatest deposition occurred near the release location, as well as toward the center of the river channel. This is one example of a new or increased discharge and alteration of background conditions in outstanding tribal resource water. The ban's anti-degradation provisions describe that only a short-term, temporary discharge can occur in outstanding tribal resource water, as long as other criteria in the anti-degradation provisions are met. Short-term temporary means no more than 6 months and no more than necessary. The proposed project will affect outstanding tribal resource waters for a longer duration than 6 months and for a longer duration than necessary. The table on the slide shows the timeline provided by the applicant for the proposed project. Based on the durations listed in this table, the proposed project's construction phase will take 137 weeks, which is substantially greater than 6 months. And this doesn't include the realistic timeframe for successful restoration or other project activities. This also doesn't include the timeframe or timeline of future water quality effects due to maintenance that will be needed. The testimony that we heard from Enbridge earlier included stating that wetland monitoring at select sites will occur for 15 years. The 15 years of necessary wetland monitoring is aligned with our understanding that will take over a decade to restore some of these wetlands. The Potato River is another outstanding tribal resource water that flows within the reservation. The Potato River is a cold water stream. Potato River and her tributaries are impacted by the proposed project upstream. This includes Bond Creek, who we discussed on a previous slide, where the proposed project will increase flow in this creek. Also, Brightwater engineers already discussed the chart on this slide that projects that the band's water quality criteria will be exceeded where Potato River flows onto the reservation due to the proposed HDD. This map shows the footprint of the proposed project, focusing on the Potato River and Tyler Forks River. When discussing Tyler Forks River previously, I noted that the USGS model simulates the Tyler Forks reach on the reservation as a losing reach. And I also read the excerpt from the USGS report that describes Tyler Forks as a potential source for contamination of the groundwater system with implications to the Potato River. This hydrologic connection also has implications to the cold water streams and springs on the reservation in this area, including the spring that Chairman Blanchard discussed earlier today. The Bad River has been discussed many times today. She is an outstanding tribal resource water and supports critical species, habitats, and uses. For example, Bad River is one of the 3 rivers on the U.S. side of the Lake Superior Basin that supports a naturally reproducing sturgeon population. Another example is that piping plovers, a federally endangered species, nest at the mouth of the Bad River. The proposed project will directly cross the Bad River. The proposed project will also cross all of her major tributaries, including Potato River, Tyler Forks River, Marengo River, and White Rivers. The proposed project will also directly cross some of her smaller tributaries. This compounds the water quality effects to the Bad River that will be present on reservation due to the proposed project. Earlier today, Chris covered the many designations that apply to the Kakagan and Bad River Sloughs complex. The Sloughs complex is a critical Lake Superior coastal wetland system. The sloughs support monomen or wild rice, including on the downstream reach of Bear Trap Creek. Tribal members harvest fish and many medicines from the sloughs. The sloughs provide critical functions and services not just for Bad River tribal members. The sloughs are locally, regionally, and internationally important. These maps, along with the maps and figures shown earlier today, demonstrate all of the hydrologic connections between the proposed project and the sloughs. This includes the hydrologic connection with Bay City Creek, which is located outside of the Bad River watershed. This includes the hydrologic connection to Chequamegon Bay and the nearshore waters of Lake Superior due to USACE. The photo on this slide shows the surface water connection between the Bad River and Kakagan River. This aerial imagery was taken in May 2013 when flows were elevated, but they were significantly lower than the large flows we've experienced in the last decade. We were able to capture this photo as our hatchery crew was on the Kakagan, and they noticed that turbidity and sediment coming over from Bad River. Our hatchery crew was on the Kakagan because that's where the band's hatchery is located, and the band's hatchery raises millions of walleye and perch that are released into the Bad River and other local waterways. So as you've heard, we believe that the proposed project will affect the Kakagan and Bad River Sloughs complex. EPA also believes that the Kakagan, Bad River Sloughs, and the Bad River are especially vulnerable to adverse impacts from the proposed project because several waters with a nexus to this watershed are already impaired and/or are susceptible to receiving high loads of sediment. With that, I want to say miigwech and thank you.
Okay, that's going to conclude our testimonies for today. I want to thank the EPA, Enbridge, and the Bad River Band for providing statements today. Session 1 of the hearing will reconvene tomorrow at 10 a.m. Central Standard Time, with the Bad River Band providing their final statements. And then we'll proceed into session 2, which will begin at 1 p.m. Central Standard Time tomorrow. And it will be allocated to hear from members of the public.